This conference will now be recorded.
Okay. Welcome, everyone. Good morning, afternoon, and perhaps some evenings as well in the call. Got a somewhat larger presence today. Um, I assume you all have received have subscribed by now in the call or in the mailing list. Does anyone have any specific remarks regarding the meeting notes from the last call? Nobody? Okay, good. Um, to summarize where we landed with the last call, we went through a couple of documents that were prepared on the Google Drive. We didn't get through everything, so we got to the IT gear specs, and I would like to continue where we left off in the last call. And there were some additions that we defined that we wanted to implement in the other documents, and we also identified a few gaps in knowledge and input. One of those gaps being the management interfaces for immersion systems, and there was no redfish knowledge present in the call last time. I believe Steve Mills is currently dialed in. He should be familiar with the redfish elements. Is that correct, Steve?
Yes, I'm here, Ralph. I can speak to it in rough terms, that's for sure, but not too much on the details.
Okay, so at least sufficient to start the discussion on that.
Yes.
So to continue where we left off last time, we just got started on the IT gear specs as a document starting point review. This is the document where I already provided some input based on the Spiritus knowledge, which is a document that describes some standards for material compatibility. We just went through some of the tables that were in there as a potential starting format for just collecting data from the different liquid providers that are involved. As in potential issues or potential compatibility information that is spread out across multiple vendors, multiple technologies. This will be a format that we can use to start collecting the data so that we can build a more concise database or a better overview distinguishing between different liquids and different types of materials that are used in electronics or in server configurations. I have not seen any additions to this yet. I would remind everyone that these documents are open for editing publicly with the links that are spread with the mailing list workstream. These documents are also referred to in the wiki. So please, I would like to encourage everyone to add to all the documents where you see fit, so we can start collecting more information and more content from all of you. We stranded at the wetted material list, where we were going to look at the type of materials that will be immersed in the immersion workstream or in the different immersion systems. And what I would like to do is to collect input or a reference to make sure that the structure that we've set out right now is sufficient to at least get started with, or whether some structural modifications are required in these documents. So please feel free to chip in and ask questions. So the second chapter is about wetted material list, and here are some items that are commonly immersed in the different types of immersion systems. Is there anything in particular that we're missing or that should be added or maybe modified, maybe restructured, or is this something that we can all start working with and collecting information with?
Hey, Rolf, I think it's a good start.
Yeah, Ralph, I agree well. Yep, it seems like a good start to me.
Okay. Is this something where who in this current call are able to provide information and content to this list? Is there anyone in particular who has information to share or to add to this, or does anyone see any more specific information that we would want to get in here? Just to give you a rough example, I know should we go into the electronics levels, like on the second line with generic electronic components? Should it be more specified, or is this pretty much the level that we need to adopt?
You do not have PSUs in the list? Ah, yes, it is. Sorry, missed it. It's okay.
No, that's right. I mean, PSUs is an interesting one as well, because there is right now here it's mentioned under thermal interface materials. Currently, I'm assuming I'm considering PSUs as an electronic device, which is just like a mainboard. PSUs tend to be more complex than a mainboard in the sense of components or build layout. They're more densely packed. I can imagine that it would warrant a different chapter by itself, or okay. So if there's no additional feedback, I'll leave this for now. I've already added some of our own content from some of Spiritus content to the descriptions with recommendations for mainboard configurations and what type of modifications can be implemented to optimize it, like fanless operation and optimize thermal settings on the main boards, which is something that should be considered when manufacturing these boards. Is there anyone who wants to add or start getting into more technical detail on this, or based on how or where this the way that this should be achieved by the manufacturers?
Hey, Rolf, I would just add that we'll need to be cognizant of PCB fabrication process, surface finishes, fluxes, and solders used.
Okay, so is that something you would like to add to this document? Because feel free to do so.
Okay.
Yeah, so it's that would be great. I know you've got quite probably have some experience with that. So you mentioned the solders used.
Yes, what kind of solder used, what kind of flux used during the soldering, and what kind of board cleaning process takes place.
You mean during the manufacturing or also in the immersion process?
Manufacturing.
All right, good.
Hey, Rolf, this is Steve.
Yeah.
The way you've got it structured, where you've got it set up by product type, you'll probably end up with a lot of redundancy, because it's probably going to be like for example, just this discussion on the fluxes is going to be relevant to your PSUs, the servers, adding cards, I mean, all the electronics, right? So rather than breaking up by product type, you might think about structuring things by just component type, right? Just PCB as opposed to like a server. or, because whether it's a GPU or a PCI card or motherboard, it's going to be the same information, right? That you'll have to kind of replicate.
Yeah, I think I would agree with that on many levels. Yes. Whereas there are fundamental differences in types of electronics. A GPU is built differently from a mainboard, and it would require different overall concerns to my experience. So if we qualify or certify a GPU individually for immersion, that goes through a different process than when we do that same thing with a mainboard, simply because the mainboard includes a lot more complexity when it comes to thermal properties or thermal shutdown temperatures, firmware type, how does that firmware react on being immersed, and that also relates to the purpose of that PCB. Now, I do agree with you, and I think there is a lot of generic input that we would want to collect for PCBs and manufacturing process. But when it comes to mainboards and the type of features versus and the types of issues you can have with CPUs, they are quite different from other components like PSUs and GPUs or other interface cards. How would you propose we distinguish between those then?
Well, you certainly have a lot more experience doing the qualification process. So your qualification tests might be different, but your expectations of those components when they go in the bath would be similar, I would think. For example, whether it's a power supply or a motherboard, both of them need to understand that there's no fan, right? Both of them need to not generate errors because there's no fan. So that's, yes, they're two different components, but the expectation is they would act the same. They're not going to throw off errors because the fan is not spinning or doesn't exist anymore. But the materials, right? You don't want the type of fluxes that you're using or the type of PVC that's used in the wiring would be the same, whether it's a PSU or something that's on the motherboard. So you're going to end up with probably the same information. Whether it's just a matter of how it's presented. So at this point, maybe it doesn't matter. You just keep presenting it kind of by, or putting the information in there by component type, like you've got it here, or I'm sorry, more, we'll call it product type, if you will. And then maybe, I guess you can look at the information when you're done to see if you need how the best way to present it is. Just something to think about.
Okay, yeah, no, I see where you're coming from. There is a distinguishment. There are two types of inputs in the same document that are going in. One is for reverse compatibility, and one is towards optimizing designs for liquid. And I understand what you mean, because if we're looking at component level standards for manufacturing all the different components, it would make a lot of sense to approach it from a more generic point of view. Whereas being reverse compatible and ensuring reverse compatibility, that will probably require different processes for different types of boards. So yeah.
It sounds like you're already kind of aware of that thought. So it's and certainly if I'm sitting down to design a power supply, it's great if I have all the information that's particular to me in one place, rather than having to go hunt through a bunch of stuff that doesn't necessarily apply to me. So I guess it kind of depends on what your audience that you're shooting it for is. More of a specification or more of a design guide. It's more of a feel. So there's nothing wrong with the way it is.
Yeah. I'll separate it for now because there might be some input related to specific components that we still want to elaborate on. But yeah, let's move towards more for future builds. Let's move towards standards on component level. Indeed, that's good. Is there anyone else who has some input on this?
Well, if it's Nigel, just looking at the main board or CPU section, I think especially for fans, whilst we don't want to, as you say, we don't want to change any construction on the board, we want to keep it as generic as possible. I think we can do fan disablement through a BIOS. So we would need a separate BIOS which would allow for power on without fans.
Mm-hmm. Yep. I think I did describe that somewhere. Okay. Yeah, that is absolutely. I think that's more of a common standards, whereas coming up with fan simulators and that sort of thing is more towards reverse compatibility. Indeed.
Yeah, definitely for reverse compatibility, BIOS would benefit reverse compatibility.
Yeah, we have some designs which we'll be open sourcing as well for fan simulators, which are very generic, can be easily manufactured for a couple of dimes, which can be easily implemented to simulate fan operation. It's a pretty open open design, and that's we know that there's, as you probably know as well, there's a lot of mainboards that don't allow custom firmwares or so they just need to be fooled.
Yeah, that's a good. It's certainly a good approach. It's quite a pragmatic approach as well.
Yeah, I have that design already somewhere online, but I'll make sure to include it in here as well. It's
so will you make
a design?
Are you planning to do that as a version for OCP?
Just generic. It's a very generic design. It's a very small. It's actually based on some designs which you can find in Google, but we've optimized the design for size to make it very small. You can easily solder it to an existing fan cable. Just cut off the cable. You can solder it to it, and it will pretend to be a fan. It will just give the pulse signal from a fan.
Yeah,
so it's something that we've already shared on several occasions, and I can share the design. I can put the design easily in OCP. It's non-proprietary in any way.
May I ask a question for just my own indication? Is this an issue that's applicable to prototype systems? Because my assumption is anybody who's buying in volume, the supplier would be able to modify the BIOS.
Yes, the problem is that this comes more from the normal market, not from the hyperscaler market. So most immersion companies like ourselves, but also Isotope and Submer are involved with installations which involve maybe a few dozen of immersion systems with a couple thousand boards, and suppliers are not always happy to or even willing to modify firmware for that level of implementation. When it comes to OCP, it's going to be a different story, but when it comes to testing, at least for the initial implementations within OCP, they will most likely be small scale, and therefore it's probably easier to fool existing mainboards instead of creating custom firmware for it.
Understood. Thank you for the explanation.
Yeah. All right. Good. Okay. Anything else? Yes.
Yes. So just of adding, I mean, we have CPU on there, and I think we should have GPU as well.
Yep. there not in here? Nope, it's not. Although there is a fundamental difference between common GPU and CPU builds. So there is a reason. Hey, that's odd. It doesn't come up with the. Okay, something is. Hey, come on. Forgive me for this. This is behaving a little bit erratic. Okay, let me do this differently. GPU. So this is something that is a good question. I have not included it yet, simply because GPUs are usually very simple builds. There is usually no heat spreader above the chip, so no thermal interface material between the chip and the heat spreader, and heat sinks are usually applied directly onto the chips, which means that there's a lot less concern when it comes to thermal transfer into a heatsink, or compatibility issue, or also less concern about compatibility issues. But it makes a lot of sense to add it to this list. And I'll elaborate on that as well. That is more or less a description of the weathered materials in this case, huh? Okay. Anything else?
So we have heat sinks as well. So, and I'm wondering here of, and maybe we will find out when we start writing more in detail, but how much will be different, right, for one-phase immersion versus two-phase immersion, right, of heat sinks versus surface treatments and stuff like that, right?
Yeah.
So I don't know exactly if we want to split it out, you know, if it becomes too complicated,
yes,
kind of the same, right? Or not.
I explicitly mentioned the term may, because one of the elements with two-phase immersion is that heat sinks are often not required at all. Because two-phase is superior in heat rejection compared to single-phase, obviously. But when heat sinks are applied, then heat sinks may make a massive difference when they're optimized for liquids. That's pretty much what the point is here. I don't know if we want to come up with actual liquids optimized heatsink designs, or leave that to the different liquid providers or server providers. I think that's a question that might be interesting to discuss.
But maybe we just want to say that the boiling enhancement coating or something like that could be used then for two-phase, right? Versus heatsink.
How did you phrase that?
Boiling enhancement coating.
Like this?
Coating.
Oh, coating. Sorry.
Yes.
now I understand. All right.
Yeah.
Rolf, this is Harold Niemeyer from Baidu.
Hi, Harold.
Hey, Rolf, I just joined. I just caught a piece of the comment that was made just a second ago, and then I think one of the things that the team may want to look at is some standardized, if we need to do some CPU or GPU heatsink or something, that maybe there's some standardized design that can work with, in most cases, in terms of different applications of different types of GPUs or CPUs. So there's some standard design that could be leveraged.
Yeah, I think that makes a lot of sense. I think that makes a lot of sense.
It would need to be scalable such that it works with the next generation higher power applications, but it should have enough that it could be leveraged. That way you can try to leverage the volume.
Where I think if we're looking at the wide range of liquids that we are all engaging with, the viscosity of the liquid is probably the most important factor for calculating optimal fin spacing for different liquids. So there should be a range of that could be interesting to actually come up with a range of standard fin spacings for different liquid ranges. Is that something that would be attractive to work with?
Yeah, I think that would be like a goal. That would be a goal of the project.
Okay, Nigel, if you don't mind me asking you a question about this as well. I mean, I know you guys are working with passive circulation as well. Are you working with optimized heat sinks for the chemical liquids as well?
Yeah, so we primarily to try and enhance the surface area for carrying the fluid, and obviously to act as a heat spreader as well. So I'm comfortable with what you've been mentioning there around it. You may want to mention something about heat in terms of overall. What's the right word? Surface area capacity.
So a technical question to you then, Nigel, is you guys are nowadays positioning the service horizontally again. Will that impact the fin spacing drastically, or is that not so relevant for the heatsink, optimized heatsink design for the OCP input?
Fin spacing is still applicable, and it just depends on the flow rates that we're looking to support.
Right.
And as you say, it comes down to a formula, and the formula could be based on amount of heat capacity that's required to be dissipated, and conduction requirements that we need to get to in terms of heat transfer.
To come up with a formula for this, that means that you come up with some information which may be perceived as fairly complicated. And I know that we're all used to working with that, as being liquid providers and doing optimization of these type of components. What about skipping out on the formula and just specifying a range of fin spacers for viscosities? Would that already do the job, in your opinion, or do we need to get into a higher level of detail?
My thoughts are that it depends on the fluid, as we've talked about. It has different heat carrying capacity as well as viscosity, so it's going to be different, and also the heat load, and it's just so many variables for us to be able to specify that. I think it's going to come down to the target surface temperature we want to achieve, or the junction temperatures that we want to maintain to keep the CPUs operating. So it's I don't think we just put a simple formula down on this.
Yeah, the thing is, we both know how complicated this can be, and I think the purpose of the OCP input is to come up with some basic standards or basic frames of reference that especially the manufacturers without the specific knowledge of all the different liquids can be comfortable with. Okay, so if I make this type of heatsink, that will apply to these liquids in this fashion. Do you think it's reasonable? It's a reasonable expectation that we can come up with some reference designs that cover 90% of the ranges that we will be working with?
Perhaps we could put some ratios in and some suggested changes to those ratios based on material type, surface area, and that would at least give some guidance because as you and I both know, it's just so many variables to consider. But let me take that one offline, and I'll come back to you and the team and see if we can make a suggestion on it.
If you would like to use me as a sounding board for it, because we're doing similar things anyway, so it might be worthwhile to discuss with the two of us as well how we can utilize our knowledge and experience combined and to come up with something with a model that would fit OCP.
Perfect. Sounds good.
All right. Cool. Perfect.
Because another option might be, right, of at least presenting the metrology of this is the way that in order to come up with your optimized heatsink design, right?
Yes, of course.
And because it will be so dependent upon the boundary conditions that you're using, right?
Yes, because each material has so different heat conduction properties, correct?
Yeah.
Is that something you would like to be involved in, Jessica? I know you have a very strong background in thermodynamics.
Sure. Yes, I would like to be part of that. Thank you.
Excellent.
All right, cool. So we'll make that the three of us then. Good. Is there anyone else who would like to join that conversation? Anyone else with a specific thermodynamic background who has knowledge and experience to chip in here?
To my 3M, I'd be happy to participate in the boiling enhancement coating area. Done years of work in that field.
Oh, excellent. That'd be great, Phil. Thanks.
All right, cool. So that's Phil Tuma, Jessica Goldbrandt, Nigel Gore, and myself. I'll probably assign one of my colleagues to it, but for now this should be okay. Great. So let's set it up in a mail chain among us, and we'll see if we can work something out to feed in here. Okay. There's a couple of things left: power supply, storage, network, specifically high-speed network in this case, but because there's a lot of questions that keep coming up on high-speed and high-performance network network cables. Is there anyone who wants to feed into any? Is there anyone who has some specific inputs or remarks or questions or elaborations on these topics?
Hey, Rolf, with regards to storage, do we have something on acoustics with regards to helium sealed drives?
No, we don't. At least not yet. So please elaborate.
So basically, if we had acoustics do whether it's phase change or forced current of forced convection in one phase, at the same time, the impact of external vibration when the hard disk drives in a fluid medium.
Is that something that, in your opinion, is a concern inside liquid as well, since there's no fans
or
other moving parts inside the liquid? Is that something that needs specific attention? Is that what you're
the fluid could be a better transmitter of acoustic waves. So there might be some guidelines on what is allowed of kind of motion or work around a tank, for example.
Okay, is that something where you have a specific experience or any more specific knowledge requirements that we need to find to add to the work stream? Or maybe somebody already is knowledgeable about this?
We have some experiments. I mean, we can share some of it.
Okay. Right.
Hi there, Daniel from Submer here. Wouldn't the acoustics actually be reduced because of a fluid, or am I getting something wrong here from the physics point of view? Because we've been doing a lot of testing, and one of the things that we're obviously mentioning is that by working in a medium like fluid, the acoustics and any types of vibrations are substantially mitigated outside. Type vibrations that come from outside of the tank are substantially mitigated by the time they reach the hardware.
This would be focused whether the fluid is a better transmitter of any vibration wave versus the air.
Okay. I don't have expertise, so I can't comment.
It's an interesting point. I agree with you, Daniel, but it's also something that we, as Aspirators, have not been investigating in depth when it comes to acoustic effects. So we don't have anything to provide here.
Myself, I was just curious. This is Harold from Baidu again. Are you talking about? Was the gentleman talking about SSDs, or what particular drive was he mentioning? Because that was a little vague for me also.
Helium-sealed hard disk drives.
Okay. Thank you.
Okay. Okay. So well, let's get some more clear description on this. If there's something that Hussam, is this something that you are capable of researching as well, or is this something that you can provide the technology providers in this work stream with some instruction on how to investigate this, if that is necessary?
We do have some experiments running in the lab about this. I will need to see how much we can share, but we can provide the experimental setup and the way to get the data.
Yes, and if there's some more information on the relevance of this, I would greatly appreciate that as well. Because I'm personally, I'm not very familiar with potential risks involved with acoustics in liquid environments.
Okay.
Thank you. Nigel and Daniel, does the same apply to you guys, or have you done any specific research on acoustics?
I think Daniel said no. From our side, we're aware of the challenges around air and the vibrations from fans. We know that by eliminating the fans, we reduce the shock and vibration. We have not conclusively tested to the volume that I think Hussam is focusing on. So something we can certainly look at in future developments.
Okay. So then, finally, as final topic of this chapter is the high-speed network. SFP, QSFP connections. There are already some extenders in the market. There are some first immersion-ready optical cables out there in the market as well. One of the ways that we could deal with high-performance cabling is to list known products to be compatible with liquids when it comes to optical interfaces. I mean, optical interfaces inside liquids are a known risk. We could also go about defining the requirements for optical cables before they can be compatible with immersion technology. Any ideas on how to approach this?
Sorry, this is Steve. So, do you have enough knowledge already where you could write a spec around what the requirements are yet, Rolf?
To my experience, we have done quite a lot of work on creating or defining compatibility requirements for optical cables, because the risks are twofold when it comes to reaction of materials, but also with the refractive index. So there are different strategies in which you can counteract that, and we have a few partners who have developed their own immersion-ready cables for oil immersion. I know that there's a couple of companies out there who have done this with 3M as well, and the type of solutions that are coming out of that are fundamentally different. So in the top of this document, I've listed some concerns. I believe, not sure if that's completely worked out. There should be a topic here on opticals. No, there's not. I will add that to the list. There are some concerns with generic optical cables, which need to be mitigated in some way, and there's different strategies to do that. So the type of solutions to become liquid compatible are there's a very broad range of solution approaches.
So I guess the reason I'm asking is unless we can like specify that, and certainly from a material standpoint, right? We could probably specify what materials are acceptable or not. To me, at that point, right, we'd almost have to turn it over to like the OCP networking group, right? Based on the protocols that because they qualify optical cables all the time. They have their own protocols you have to run test cases against. I would think, we could certainly talk to them, but I would think we would just expect these cables to do the exact same thing that they're already running the test suites on, the OCP test suites. You just have to also do it in whatever materials that it's qualified for. So that's kind of a generic way of doing it, but unless that's effectively what we want, though, right? Is to be able to run the same speed, same protocols on the equipment, just to be able to do it in different baths.
Yeah. So one of the ways to solve this is to create completely sealed connectors, which one of our partners has done, which are completely liquid-proof for any type of liquid. But that's one strategy. I know of another solution where the manufacturing process is modified in such a way that all the critical components cannot be affected by the liquid. So I think I'm answering my own question myself here, that I don't think it makes sense to establish specific requirements to the cable, except for the fact that the cable should be protected from any effects from liquids, probably.
The thing is that you can't make an optical connection. So the only thing you can put in the oil is the SFP with the optical connection sealed.
Yes.
That should be, I think that should be written, because in terms of maintenance, if you want to change the cable, you have to remove the SFP, and you don't have to remove just the cable if you want to change just the two optical things and put back the optical things. You can do that on some SFP. So that I think that should be, if you want to make an immersion, you should not make the optical to SFP connection unpluggable. That should be sealed, because that's the issue we had in immersion. I saw in immersion in previous life, is because you have a bubble of liquid inside your optical connection, and the diffraction of the bubble is making is crushing your signal.
Right. Daniel, I'm pretty sure that you want to respond to this, because you have solved this from a completely different angle, haven't you?
Yeah, we've tested 40G links fully submerged in the fluid, and we've tested it with third parties and can confirm that it's ready for production. Again, a little air bubble, not a fluid bubble, an air bubble in the wrong place will completely mess up your connectivity. So although in the case of the specific fluid we're developing, we can submerge fiber optics. I'm personally more in favor of course, having cables that completely avoid this issue, and that are obviously also fully compatible materials with the different type of fluids out there. So although it is possible to run 40 gigabit links and probably 100 as well, which is the next phase that we're testing now, I think it's safer for production environments where people won't be so careful and paying attention to these connections that you can have these sealed optical SFPs.
Do you have a suggestion whether this should be rephrased?
No, I think it's fine. I think it's fine. I mean, we can mention that it is possible there are certain fluids out there that will allow you to submerge fiber optics without protected SFPs, but it would just be like to inform people that it is actually possible. I wouldn't recommend it for large scale production environments.
No, I agree, and I think the whole purpose of this is to come up with a concise, with a generic design approach which covers as much as possible without requiring different specs for different types of implementation. So, this, to come up with a standard for that will work for everything is probably the best strategy here, I assume.
Yeah, absolutely.
Okay. Okay, then there is some guidelines and best practices still. Existing hardware compatibility and a warranty guidelines. I know that Daniel, you wanted to add specifically to that chapter.
Yeah, and there I wanted. Sorry to interrupt there. There I wanted to ask you. So obviously we have a active flow in our technology, and that allows us to use hardware that isn't specifically designed and built for immersion cooling. How would we, and where would we position that in these documents? Because I think it's also important that people are aware that there are solutions out there that allow you to take IT off a rack and stick it in a tank and use it practically in the same way.
That would be right here. I take it. So the wetted material list and this whole document up to chapter 5 would be referring to current design and current build hardware. Where chapter 5 I started including information towards optimized design. Designs optimized for liquid, where that's always forward compatible. So the optimized design for liquids are not specific for Asperitas. They would work very effectively in your solution as well. So that's part of the knowledge input here. And chapter 4, the existing hardware compatibility and our warranty guidelines is, I believe, precisely what you're looking for, right, or not?
Okay. Then we'll start working in this section with what we have to date. Then, thank you.
All right, perfect. So we're reaching the end of our time slot. There's another call starting in a few minutes, so we need to wrap this up. I suggest in the next call we'll continue on this. In the meantime, I would like to urge everyone to start adding to these documents and providing some contents where you see fit, where you have knowledge. If you like to be specifically engaging on a specific topic, feel free to put your name in there, but know that this is a public document. It's publicly accessible. For the next call, I think there is also a timing issue regarding it might be a difference in the date that saving time kicks in. But apparently the subsequent calls are scheduled an hour later again, but the US base time is still the same. So it's something that we need to sort out with OCP, because the intention is to maintain the Central European time frame for this from 4:30 to 5:30. So you may expect again an update of the schedule soon. Are there any final questions before closing the call? Okay, if not, I would like to thank everybody for the participation, and I'm looking forward to hearing you all again in 2 weeks from now.
Thank you very
Thanks,
much.
Ralph.
Thank you.
Thanks, Ralph.
Thanks.